In this video, we'll be looking at how to find the determinacy of these structures, whether it is statically determinate or statically indeterminate structures. Before that, let's recall our equations of equilibrium from statics that we have. We know that for any structures in 2D plane, the summation of forces in its x-axis would be equal to 0. The summation of forces in y-axis would be equal to 0, and then the summation of moment at any point in structure should be equal to 0 to maintain its equilibrium. Right? So we have three equations of equilibrium. Now, statically determinate structures are those structures whose internal forces or unknown reactions can be solved by just using these equations of equilibrium. Whereas statically indeterminate structures are those structures which require further analysis method to solve their unknown member forces and reactions. Just using these three equilibrium equations are not enough to solve those forces. So to classify any structures, whether it is determinate or indeterminate, we need to find the degree of indeterminacy. And degree of indeterminacy actually refers to the number of unknown forces in any structure that exceed the number of available equations of equilibrium. So for determinate structures, you can just use these three equations of equilibrium to solve these structures. That means the degree of indeterminacy would be equal to 0. Whereas for statically indeterminate structure, the degree of indeterminacy would be greater than 0. Let's look at some examples for the beams first. For beams, we calculate the degree of indeterminacy by using this formula r minus 3n, where r is equal to number of unknown force and n is the number of members. So degree of indeterminacy is the number of unknown forces that exceeds the number of available equilibrium equations. Right? So for each member, we know that there's three number of equilibrium equations. So we multiply this number of members by 3. That's like 3 equation of equilibrium. Let's look at this example. Here there's one beam and there's roller support here, and then it's fixed at the right. So at this point there's one vertical reaction, at this point there's going to be another vertical reaction, and then at this point there's going to be horizontal, vertical, and then moment reaction as well. So from this we can see that r, which is number of unknown forces, there are 1, 2, 3, 4, 5. And then how many number of members? There's only one beam. That means there are 3 equilibrium equations. 3 times n would be 3. So its degree of indeterminacy would be r minus 3n, which is equal to 5 minus 3, which equals to 2. That means the degree of indeterminacy for this structure is greater than 0, so it is statically indeterminate. We cannot solve the unknown forces just by using 3 equilibrium equations because it is statically indeterminate to 2 degrees. Or we can also say that there are 2 more number of unknown forces than the number of available equations. In this example, this beam is fixed at both ends, so it's going to have a reaction here. It's going to have reaction here. That means that the total number of unknown forces are 6, one beam, so 3n would be 3. That means the degree of indeterminacy would be 6 minus 3, which is 3. And again, this is statically indeterminate structure with 3 degrees. That is, it has 3 more unknown forces than the number of equations of equilibrium that we have. Let's look at another example for the beam. Let's draw free body diagram. BC at C, it has a pinned, so it's going to have horizontal and vertical reaction. At this point B, it's going to have a roller support, so vertical reaction, equal and opposite reaction at the same point for another free body diagram at B. And at point A, it's fixed, so it's going to have vertical, horizontal, and a moment reaction. So total number of reactions, unknown forces are 1, 2, 3, 4. Remember, this is only 1 because this is just to represent that it's equal and opposite to maintain the stability or equilibrium at this point, but there's only 1 forces at this point B. So 1, 2, 3, 4, and then 5, 6 number of unknown forces. Number of members, there are 2 beams, 2, therefore 3n is 3 times 2, which is 6. So degree of indeterminacy would be r minus 3n, which is equal to 6 minus 6 equal to 0. That means the number of unknown forces are equal to the number of equilibrium equations that we have. So we can solve this problem, and it is statically determinate. Here's another example for the beam, which has a pin connected members. Again, let's draw a free body diagram, separate at the pin connection. At this point, there's a pin connection, so it's going to be horizontal and then vertical reaction. This is a rocker support, so it's we only have vertical reaction. At pin, internal forces, horizontal, and then shear. Same here at the same point, equal and opposite to maintain equilibrium. And then at this point, pinned, so vertical and horizontal reaction. And at pinned connection, there's no moment. So number of unknown forces would be 1, 2, 3. Again, this is same point, so only count once. So 1, 2, 3, 4, 5, 6, 7. 7 unknown reactions or unknown forces. How many elements? There are 2 elements. That means 3 times n would be 6. Therefore, degree of indeterminacy of this structure would be r minus 3n, which is equal to 7 minus 6, which is equal to 1. That means that this structure is also a statically indeterminate to 1 degree. For the frames, we are still using the same formula. We're calculating the unknown forces, and then we're calculating number of equilibrium equations that each frames has. But the process here would be to look at the closed loops and cut through that section. So let's say this is A, B, C, D, E. In this closed loop, if we cut through one section and find out its internal forces, then in the whole loop we can find the internal forces at any point of this structure, right? So look for any closed loop, draw a free body diagram, and then the number n would actually be the number of free body diagrams that comes out after we cut the sections. When drawing the free body diagram, let's say we cut at these points like this. So internal force at this is here, same point but equal and opposite forces, moment, and then same in this case, moment, and it's fixed at the bottom. So we are going to have vertical reaction, horizontal reaction, and then the moment reaction. Same at this point, vertical, horizontal, moment, vertical, horizontal, moment, right? So this means that how many unknown forces do we have? 1, 2, 3, 6, 9, and this is again not 6 but only 3 because it's the same point. So 3, 6, 9, 12, and then 15. So we have 15 unknown forces, and n would be equal to what? There's 3 free body section, 1, 2, and then 3. So n would be equal to 3. Therefore each free body section would have 3 equations of equilibrium. So 3 times 3 is equal to 9. And degree of indeterminacy for this structure would be r minus 3n, which is equal to 15 minus 9. So this structure is statically indeterminate to 6 degrees. Let's look at another example for frames. Again, same thing, same formula. The process is look at the closed loops, this, and then cut through those. Cut through the section. I'm going to draw the free body diagram for this. Pinned at this, so vertical and then horizontal, vertical, horizontal, and then moment, vertical, horizontal, and then moment here. Now that we have a free body diagram, let's count the number of unknown reactions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over here, right? And then 3, this is the same point, so 3, 6, 9, 12, 15, 18. So 18 plus 10 will be 28 number of unknown reactions, and n is number of free body diagrams section that we have here. It's like 1, 2, 3, and then 4. So 3n would be 3 times 4, 12. Degree of indeterminacy would be r minus 3n. 28 minus 12 equals to 16. So this structure is also statically indeterminate to the degree of 16. Now finally, let's look at trusses. For the trusses, we have one more concepts to keep in mind before proceeding. So this is the formula to find whether it's statically determinate or indeterminate. So degree of indeterminacy would be r plus b minus 2j, where we know that r is number of unknown forces. The b is number of unknown member forces. So in a truss, each member will have its axial force, whether it's like tension or compression. Those are the unknown forces that we need to add on, and then j is equal to joints, number of joints. So simply, like, the degree of indeterminacy in truss can be found out by adding the total number of unknown reactions plus the each member will have its own unknown forces minus the number of joints times 2, because its joints are pin connected, and then the moments are 0 on truss joints. So it will only have 2 equations of equilibrium. So we sum up the total number of unknowns that are reactions and member forces, and then reduce it by total number of equilibrium equations. That's 2 times the number of joints. Let's look at this example. At this point, this is rollers, so it's going to have horizontal reaction. At this point, there will be 2 reactions, and then at this point pin connected, so 2 reactions. So we know r is equal to number of unknown forces or reactions 1, 2, 3, 4, 5. Now b would be equal to 1 number of members, 3, 4, 5, 6. There are 6 members, so 6 unknown member forces, and then number of joints are 1, 2, 3, 4. So 2 times j is 2 times 4 equals to 8 number of equilibrium equations. So its degree of indeterminacy would be number of unknowns are 5 plus 6 minus number of equilibrium equation is 8. So 5 plus 6 11 minus 8 3. So this truss is statically indeterminate to the degree of 3. That means there are 3 more unknown forces than the number of equilibrium equations that we have. Let's look at this truss. So it has a pin support here, a rocker support here that acts like a roller support. So it's going to have 2 reactions, horizontal and vertical here, and then only vertical reaction here. So the number of unknown reactions forces are 3. Number of unknown member forces will be equal to number of members. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 number of unknown member forces, and then the number of joints 1, 2, 3, 4, 5, 6, 7, 8. 8. That means each member has 2 equation of equilibrium. So 2 times 8 would be 16. Degree of indeterminacy would be equal to total number of unknown forces that are r plus b, 3 plus 13, minus 2 times j, number of equations of equilibrium 16. So that's 16 minus 16, which is equal to 0. That means truss is statically determinate. So this concludes our video here, and I hope you understood how we can classify structures as statically determinate or statically indeterminate structures.